Okay, folks, this is chapter 3, and we're going to look at gamma in this chapter. So we're looking at the spiders here, and the markets have just closed about an hour ago, so you don't see the prices moving like we did earlier. But what I've done is I've pulled up the spiders, and we're looking at the May 2012 options, which has about 60 days to expiry. And also you can see that the spiders have closed at $140.85. I've also listed two columns here. One is the delta and one is the gamma. And in this chapter, we're going to look at gamma. The best way to understand gamma is a little tricky to understand because it's the second derivative of price, also defined as the rate of change of delta. So it's a little tricky. So what I would do is I'm going to just focus on calls because puts can make it a little bit harder to understand because of the negative sign involved in the puts. What we'll do is we'll just focus on the calls and understand the concept of gamma. The concept of gamma works the same whether it is calls or puts. So once you've understood the concept here, you can certainly translate that knowledge onto the put side as well. So let's focus on the call side and try to understand gamma. Gamma is defined as the rate of change of delta. So what we mean by that? Now, we saw that the at-the-money options, for example, the 141 call is still the at-the-money option, and in fact, it just changed to 50. Anyway, so this is an at-the-money option for the spider, and it has a delta of 50.5, that is. Now, what we are saying is it's the rate of change of delta. We know that delta is the amount the option will change for a $1 move in the underlying. So we have the spiders trading at, let's say, 141. So, but we're looking at a 50.5 delta on the 141 call. And if the spiders move to 142, then this option will increase by 49 cents or 50 cents, whatever the case might be. But once it increases, what is going to happen to this delta? Now this option is now going to be in the money because it's the spiders move to 142. In fact, it would be like this one right here because it would be about $1 in the money. So the rate of change of delta, so you can see that the gamma for this option is 0.05, and if the spider goes up $1, the gamma of 0.05, so 5 cents of gamma is going to get added to this delta value. And that's how the delta of the $1 in the money option is going to be 54. Because all you do is look at this delta, 0.49, and then you add the gamma, 0.05. And so if the spider moves $1 in the money, this option, which has a delta of 0.49, will have a delta of 0.54. So that's how this works. And then if it goes another dollar, it's going to be 0.54 plus 0.04, which is 0.58. So you can see that the delta is going to change. And not only is the delta changing, the rate of change of delta will also change. So here we saw that the delta changed by 5 cents. Here we're looking at it, it's going to change by 4 cents. And then the next three are all 4. However, what we have here is only listed up to 2 decimal places. And if we put up the option screen with 4 decimal places, you will see differences in these values as well. And then as you go in the money, the gamma reduces. And then finally it becomes 0.2, and then it'll become 0.1. So that's how gamma works. If the option moves in your direction, then your delta is going to increase. But if it goes against, then your delta is going to decrease. So if it went from 141 to 140, then what happens is the delta is going to be 0.54 minus 0.05, which will be 0.49. So it's going to work the other way if it's not going in your direction. So if you've bought an option, you're generally positive gamma, you're positive delta as well as positive gamma. So one of the things to note right away, there are actually 5 important things about gamma. Okay, the first one we just discussed. It is the rate of change of delta. And you'll notice that gamma is highest when the options are at the money. So why is it highest when the options are at the money? That's because the at the money options have the most uncertainty associated with it. So because it's straddling, it's either neither here nor there. So it can go in the money, it can go out of the money, and therefore those options are usually the most jumpiest. So they jump around here and there, and that's why their gamma is also the highest for the at the money options. So that's the first thing you have to remember. As you go in the money, you'll see that the gamma is reducing. So if you look at the 131 call, the gamma has reduced to 0.02. And similarly, if you look at the out of the money options, it's also reduced to 0.02. The at the money options have the most gamma, and as you go out of the money or in the money, the gamma is going to reduce. So that's the second important item that you have to know about gamma. The third important item is that as you approach expiry, gamma is going to be much more impactful, and gamma is going to be a higher value in the first place, and gamma is also going to be much more impactful. So gamma has a much larger effect as the options approach expiry. So let's see this in action. So we got the May options here. We know the at the money gamma here for the call options are about 0.05, so 5 cents. Let's now look at what happens in the April series. You can see that the same option, now the gamma is 0.07. So from a 49 delta, if the spider goes up, then the 141 call option will go in the money, and once it goes in the money, its new delta is going to be 0.56. So at that point, for every dollar move in the spider, this option is going to move by 56 cents and not 49 cents. And then if it goes further into the money, the next time for the next $1, it's going to move 62 cents. That's because 56 plus 6, so we have 0.56 plus 0.06, so it's going to move 62. Similarly, 62 plus 6 is 68. 68 plus 5 is 73. But you notice that the gamma has increased in the April options. Now let's look at the March quarterlies and look at the same 141 call. There it is, and you see that the gamma is 0.13. So for the same $1 move in the spider, the delta of this 141 call option is going to jump from 0.49 to 0.61. So that's a big jump. And then from 0.61 is going to jump to 0.72. And if you notice that there are some additions not looking right, it's because of rounding error. All Greeks are calculated up to 4 decimals actually, but we are just showing 2 because then the screen becomes full of numbers and it gets confusing to look at. So I've rounded everything to the second decimal, and therefore sometimes you'll see that the numbers don't add up, and that's because of rounding. So we saw that the March quarterly, which expires in 11 days, the gamma has now increased to 13 cents. So now the way to visualize this is these options are going to move very quickly. The delta is going to move very quickly. So for $1 move in the spider, the delta is going to go from 48 to 61. And for a $1 move down, it's going to go from 48 to 35. Okay. So you're going to see very quick movements, and that's because we are approaching expiry. So there should be, you should be able to visualize this logically. Time is running out and these options are at the money. So they can go either in the money or out of the money, and they keep jumping back and forth. And so there's a lot of jumpiness around with these options as you approach expiry. And let's just look at one more, the weekly options. And And then I want to tell something about the expiry and the delta and gamma, what happens to them at expiry. So let's look at the March weeklies, which have only 4 days left. Now you see the gamma is really kicking in. The gamma is 23. So for $1 move in the spiders, the delta is going to move from 48 to 68, and from 68 to 83, and so on and so forth. Now you can see that these options already have a 1 delta. So basically they have 100 deltas. The 135 call is deep in the money, and it's going to move in lockstep with the spider prices. So basically what this 1 delta is telling you is that for every $1 move in the spider, this option is also going to move $1. So it's moving in lockstep with the underlying stock. The gammas, when you approach expiry, is going to be very high. And if you notice, the gammas quickly run out to zero as you approach expiry, because these options really have no chance of going out of the money, and these options, which are already out of the money, have no chance of going in the money. Its delta itself is 0.01. So for every $1 move that the spider makes, this option is going to move 1 cent. And then the gamma effect is also 1 cent. So maybe the next, if it moves $1, then this option will move 2 cents the next for the next $1. So these really have no chance, and that's what these deltas and gammas are telling us. It's only when we come somewhere here that you have a 25 delta. So which means it has approximately a 25% chance of going in the money. And that's because the time left in this option is only 4 days. So to move from 140.85 to move to 142, that's about $1.2, $1.20 on the spider, which means that's about 12 points on the S&P. So it's possible, and you'll see that if it starts moving in towards 142, you'll see that these deltas are going to change very rapidly. So for the first $1, your gamma here is 0.19, so 19 cents. So your delta is immediately going to jump from about 24 to about 44, 45. So these things are going to change very quickly as you approach expiry. So that's the third thing you need to know about gamma. So gamma affects delta very strongly as you approach expiry, and gamma is always the strongest for the at the money options, and that is regardless of which month you're looking at. For any given month, gamma will be highest for the at the money options, because the at the money options are the most jumpiest. There's another way to understand gamma. If you have an at the money option, if you've bought an at the money option, actually let's go back to our May series, and let's say you own this option, the 141 call. If this option is going in the money, or if it's going out of the money, you'll see that the gamma will reduce. On the other hand, let's say you own this option, the 146 call. Now the 146 call is out of the money, so the spider has to move from 141 to 146 for this option to become profitable by expiry. But let's say it does start moving towards 146. So then for every dollar that the spider moves, this particular option is going to start coming closer to at the money. So it might move till here, and then for the next $1, it might be just 3 strikes away from being at the money, and then it might be just 2 strikes away from being at the money. Now as it approaches towards the center, towards the at the money, its gamma is going to increase, and therefore its rate of change of delta is also going to increase. So we can see that here. If this was a 25 delta, it goes up by 4 cents, it becomes a 29 delta. but the next one jumps by 5. So it becomes a 34 delta, and so on. So, and if you look at the 4 decimal places of these three, you'll notice that there is a jump in these options as well. So the other way to look at it is, okay, are you approaching at the money or are you going away from at the money? And that works for whether you're out of the money or in the money. If you're moving away from the center line, then the effects of gamma are decreasing. If you're moving towards at the money, whether from this side or from this side, if you're moving towards at the money, then your gammas are increasing, and therefore your deltas are going to change at a faster rate. So it's kind of you've stepped on the gas pedal on your car and the car is speeding up. So that's the way you have to think about it. And if you're moving away from at the money, your car is slowing down. So your speed is reducing, and the rate of that reduction is also slowing down. So that's the way you can visualize gamma. But gamma becomes very important only when you're approaching expiry. And so as you can see, here the deltas have started to move around quite a bit, but once you come down to the quarterlies, which have 11 days, now your deltas are really going to jump around. For $1 move, it's jumping from 48 to 60. But finally, in the last 1 week, now your deltas are really going to jump around from 47 to 66 to 80, or 47 to 24 to 10. So a couple of dollars move in the spider can make or break your position, because your option prices are going to really jump around at that point. So that was the fourth important point. Finally, I want to show what happens at expiry, because at expiry, all options are either in the money or they're out of the money. There is no in between. There's no middle ground here. You're either in the money or you're out of the money. And if you're in the money, it doesn't matter how deep in the money you are. You're going to have a delta of 1. And if you're out of the money, you're going to have a delta of 0. It doesn't matter, because at expiry, everything is either 1 or it's 0. So if you look at what happens on the last day before expiry, at that time you're probably going to see gammas of 30 cents or even 40 cents. So this is going to be really moving extremely fast, and that's why my personal preference is I don't like to play expiry, because there's just way too much volatility going on within these option prices. So I personally don't like it, so I don't play that. But I have played options up until about a week or maybe even 5 days before expiry. But at that point, I try to close out all my positions, because gamma effects are just way too strong. So that's as far as gamma is concerned. The next one I'm going to do is Vega, and I'll see you there in the next chapter on Vega.